Good afternoon and welcome to Webinar Wednesday. My name is Callie Huff and I'm the marketing manager here at Varitec, and I am the program coordinator for Dan's educational platform. Our presenter today is Dan Hahne. He's our director of high performance HVAC solutions with Varitec. You can scan that QR code if you wanted to get to our link tree that has all of our socials on our website. And don't worry if you missed it, there'll be another one. This is what our educational schedule is looking like for the year. As you may have noticed, the dates as we come up, sometimes they might change a week or two before or after, just depending on how the year starts going, based on what we chose at the beginning of the year. So we are in May, so we have a guest speaker next month, and then we have August, September, October, and November to finish out the year. We have an educational resource library where the presentations live, where you are also able to download the PowerPoint slides in PDF form. We also send out a monthly and quarterly newsletter. I'm sure that if you're on this call, you probably already get it, but if you don't, feel free to send me a message and I'll make sure to add you to our email list. There's that QR code again that I promised. So a few housekeeping items while you guys are all scanning that QR code to follow us on all of our social media channels. We are recording this session, as I mentioned. If you do have any questions throughout, please pop them in the chat. If you need a PDH or AIA credit, make sure that the name that is displaying is something that I can figure out who you are based on how you registered. That way I can give you your proper credit. If it's not something I can figure out, I will send you a personal chat during this meeting. As I mentioned, our presenter today is Dan Hahne. Dan has a wealth of knowledge in our industry. He has his chemical engineering degree from U of A. He got his master's from Boston. He also went to college in London. He has a lot of experience, just about 40 years now, in our local industry, where he worked for a couple other rep firms until 2016 when he decided to join Varitec. He is also very active in ASHRAE. He has been a member since 2009. He is on the Standards 200 2015 voting member. He's a voting member of that committee. He is also on TC 1.7P, and he's a distinguished lecturer. Also in his portfolio is quite a few publications that he has had in Engineered Systems magazine. So with that, Dan, I will hand it over to you.
Kelly, thank you very much. And thank all of you for joining us today on today's topic, Building Decarbonization, ASHRAE's Position, Purpose, and Plan. My name is Dan Hahne. And before I begin today, I really would like to provide a disclaimer. The views that I express in this presentation are my views based upon ASHRAE's published information, their documents, their various positions and resources. So I am not speaking, though I am a DL, officially on behalf of ASHRAE in this presentation. Today's agenda, however, we're going to do a deep dive into what ASHRAE has actually done to support their initiative to promote the decarbonization of the built environment. We're going to start backwards today. We're going to actually start with ASHRAE's references. And then we're going to go into the origins of the whole problem of carbon. That's the origin of carbon itself, and how does it occur, and how does it contribute molecularly to greenhouse gas capture, or greenhouse gas emissions being captured within the atmosphere and irradiating radiation back to Earth, causing our greenhouse gas emission issue. We're going to cover ASHRAE's task force for building decarbonization. We're going to look at ASHRAE's position document for building decarbonization, which is going to be the meat of today's presentation. We're going to look at ASHRAE's Center of Excellence for Building Decarbonization that was launched July 1st, 2024. Then we're going to look at decarbonization and relevant ASHRAE standards, and then a couple of concluding remarks. So let's first of all begin with references that ASHRAE brings forward in their position document. It lists all the standards that they've published to promote decarbonization within the built environment, from ASHRAE standard 90.1 and 90.2 to standard 100, to a new chapter in their handbook, chapter 36 on climate change. And by the way, our featured speaker in June will be Dr. Janice Means, who will be speaking about climate change. I believe she's going to call her presentation Myths and Realities. Then it references ASHRAE's task force for building decarbonization. It also references Standard 34, 90.4, 147, 105, 189.3, 282.8, or 228. It's actually 228, 2023 now. I just learned a few minutes ago. And forthcoming will be Standard 227 on passive building design standard and Standard 240 that will evaluate greenhouse gas and carbon emissions in the building design, construction, and operation of buildings. So the reason why I began with references first and foremost is to get a better understanding of ASHRAE's commitment to decarbonization in the built environment, the extraordinary amount of investment that they have made to support this initiative, which only goes to suggest that, well, they see an urgent need to do that. So let's go ahead and begin. Let's look at carbon's origin and thermal equilibrium. Where does our carbon come from? Carbon, the fundamental element of life, is created in the core of large stellar masses. It is a byproduct of the triple alpha process that fuses 3 helium-4 nuclei into one heavy element called carbon-12. It is the byproduct, carbon is the byproduct of stellar nuclear fusion. And when a star uses up its hydrogen and its hydrostatic equilibrium is tilted towards gravity, stars begin to collapse, they get hotter, and they start fusing more heavier elements. Carbon is one of those elements. Then, when a star has burned up sufficient amount of its hydrogen and other heavy elements that are consumed in large enough stars, they actually result in a violent projection outward of this stellar material that seeds interstellar space with material elements and molecular compounds. Well, how much carbon is in the universe? Well, 70% of the universe is hydrogen. In fact, the planet Jupiter and the planet Saturn are predominantly 70 to 80% hydrogen. There's 28% helium, and for oxygen throughout the universe, it's about approximately 1% of all available elements. Carbon comprises 0.5 of 1%. Now, it's rather interesting if you look astronomically in the elemental makeup of the cosmos, you'll find that there is some solar systems are actually oxygen dominant and others are carbon dominant. Carbon dominant solar systems are unable to support life as we know it. In our own solar system, only 2 planets have oxygen in their atmosphere. They are Mercury and Earth. So having an oxygen dominant atmosphere is unique. Earth's atmosphere is comprised predominantly of nitrogen, 78%, oxygen, 21%, and look at carbon. Carbon dioxide is approximately 0.42% of total elemental compositional makeup in our atmosphere. So a small amount of carbon does actually inhibit the irradiation of energy from Earth back into space during our nighttime conditions. So Earth's greatest energy source is, of course, the sun. The sun radiates upon Earth about 342 watts per square meter of surface area across the surface of the Earth over the average of a year. That's 173,000 terawatts of solar energy that strikes the Earth every second, 10,000 times greater than the world's total energy use. And all of this energy is completely renewable. Well, Earth also radiates energy, not only the re-radiated energy of the sun, but also its own heat generated in our core. The actual emission of radiation of the Earth's surface is 398 watts per square meter, and that radiation radiates into space, especially during the nighttime. Well, the absorption and irradiation of energy on the Earth's surface is in a somewhat sustainable, steady state of exchange, which gives us a somewhat consistent climate pattern. Atmospheric gases, however, can inhibit radiant energy flow. Certain gases called greenhouse gases, such as CO2, carbon monoxide, methane, can inhibit energy irradiation into space, especially during the nighttime conditions. These atmospheric greenhouse gas concentrations are increasing, and increasing greenhouse gases are reducing Earth's energy irradiation of space. So how is it that CO2 acts as a radiant inhibitor? Well, it has to do with the molecular structure of carbon-12 and its vibrational modes. Its molecular structure has two vibrational modes for stretching and bending, which means that each molecule can absorb infrared energy, and when it does that, it expands and stretches. But as soon as it does that, it immediately releases because all of the universe is tending towards steady state. So there's this reciprocity of action between assumption of energy and radiation of energy. However, if that happens to surface energy from the Earth that has a direct line of sight to interstellar space, and that energy is captured by carbon-12, where that energy is re-radiated is random. It doesn't necessarily go out into space. So consequently, a percentage of it comes back to Earth. And it is this continual capture or re-radiation of that energy back to the Earth's surface that results in our greenhouse gas emission. So this is what our greenhouse gas issue and our global warming conditions. So a portion of the energy radiated from Earth is actually captured in carbon-12 and redirected back to the Earth's surface. That also applies for water vapor, H2O. Ozone is also a greenhouse gas. Carbon monoxide, or methane. These are all radiant inhibitors. And by their trapping of energy, we have a gradual buildup of energy around the Earth's surface that is causing the gradual warming of our planet. NASA had some pretty interesting data that I found in researching this presentation. And I found a document that the concluding remarks state that the current warming trend is different other than previous historical warming trends because it has to do with the result of human activities since the mid-1800s and the birth of the Industrial Revolution. From the measured impacts of increases in these gases, there is no question that increased gas levels warm Earth in response. On the bottom of this slide, you have a slide that shows 50 years of how CO2 concentrations have been increasing at Mauna Loa Observatory, which is one of the global sites for measuring CO2 concentrations, and it sits at 11,000 feet in Hawaii. And you can see that in the 50 years referenced here, that there has been a 25% increase in CO2 concentrations in the Earth's atmosphere at 11,000 feet. So that's a significant increase. Doing my research, I came upon an article by the Berkeley Earth group that publishes an annual report, and their 2024 report states this, that the 2024 year was the warmest year on Earth since 1850, exceeding the previous record just set in 2023. The last 10 years have included all 10 of the warmest years observed an instrumental record. The global annual average in degrees Fahrenheit of global temperature increase is now at about 3 degrees, 2.91 plus or minus 0.11 degrees Fahrenheit, above the average that would have been considered between 1850 and 1900. During 2024, the Berkeley Earth Annual Report goes on to state, 24% of the Earth's surface had a record warm annual average locally, and none of the Earth's surface had a record cold annual average. So this suggests that Earth is certainly moving in the direction of warming up. And here are some graphic global illustrations to demonstrate local temperature increases throughout 2024. You can see that there are only some light blue areas in Antarctic off the coast of off the western coast of South America and off the eastern coast of Greenland, interestingly enough. And if you look at the global illustration on the right, or the global map on the right, you will see that there was no area on the globe that had a low near record cold recording. So this bit of data I'm bringing forward to give some understanding of why ASHRAE is responding aggressively toward the problem of decarbonization. So let's look at ASHRAE and its task force for building decarbonization. In Atlanta on March 3rd, 2021, ASHRAE announced the formation of their task force for building carbonization. And the ASHRAE formed the task force to address climate change through responsible decarbonization strategies. The task force was established to develop technical resources, to provide leadership and guidance to mitigate the negative carbon impact of buildings on the environment. It went on to say that ASHRAE has much to offer in this regard. The challenges of decarbonization are very complex, and that they are. But this task force is positioned to offer actionable technical guidance to address it. The task force went on to offer these following comments, providing that it provides the recommendations and practices for industry stakeholders in decarbonization for the built environment. It defines the objectives of this holistic initiative. It's not just a question about reducing the element carbon or carbon-12. It's also about developing a framework for characterizing the issues of carbon and decarbonization, for identifying existing portfolios of ASHRAE technical resources that can be drawn from to improve our designs to reduce building carbon generation. It provides identifying and quantifying knowledge gaps for policymakers and stakeholders to actually make informed decisions regarding local government policy and or manufacturers and the type of product they might produce. It goes on to state that its purpose is to formulate a value proposition as to why ASHRAE is embarking on this journey, and I hope to accomplish some of that today. It goes on to identify the global audience that this is relevant for, as well as to provide the guiding principles that should frame the movement forward for creating a decarbonized environment. It also provided, the task force did, a list of the various standards that ASHRAE had already written in 2021. It's 13 pages long. I obviously didn't have enough time to put it here. But you can certainly access the website. All of these documents are there, but I will show you later that they've also been updated in the Center of Excellence for Building Decarbonization. So let's look at one of the products that came out of the Task Force on Decarbonization. That is ASHRAE's position document for building decarbonization. And this is where we're going to spend really a lot of our hour today. It's in this document because it really gives a good picture of ASHRAE's direction. On June 26, 2022, President Chuck Gulledge and President-elect Mick Schwedler announced the launch of the position document on building carbonization. I went on to say that jurisdictions globally are confronting climate change and recognizing that building decarbonization is an important component in their efforts. It goes on to state that as the standards authority for energy usage in building, ASHRAE recognizes their long-standing initiatives in energy efficiency should be expanded to building decarbonization. ASHRAE's position document was updated January 24th of this year. In this document, it has added the following language: that ASHRAE position documents are approved by the Board of Directors, by the ASHRAE Board of Directors, and express the view of the society on these specific issues. Goes on to say that the documents provide objective, authoritative background information and will be helpful in drafting sound policy to address decarbonization. The documents also clarify ASHRAE's position for its members and building professionals, in the hope, I would think, that the whole of the community would begin to work aggressively to address building decarbonization. And then uniquely, at least from the standards I've read of ASHRAE, it makes this statement: that building carbonization is a public interest issue. It goes on to say that building decarbonization is imperative for global climate stability, energy security, and the general well-being of communities. And it goes on to say that the building sector accounts for significant global greenhouse gas emissions, and prioritizing decarbonization action directly serves the public interest. So it's interesting that ASHRAE recognizes its role as the standards writers for HVAC systems for its role on social issues. It goes on to say that building decarbonization for today and future society, that addressing this issue has the potential not only to help mitigate climate change in the short term, but also to provide a stable environment for future generations. It also takes on a broader context that by addressing carbon generation, the benefits extend beyond that. It can also result directly and indirectly, I would argue, improved indoor air quality, greater energy efficiency, community health, social equity. And it goes on to say that for building decarbonization to be successful, it requires robust research and development, industry standardization. And this is pretty interesting, because when I read that, it came into line why Guideline 36 on the standardization of sequences of operation for building controls was written by ASHRAE. It was written as an effort to begin to standardize how buildings are controlled so that systems can achieve and maintain their system efficiency. It goes on to say that there has to be effective government policies and workforce development. And I thought this was interesting, that ASHRAE now sees itself in the role of helping to equip the future workforce with the skills necessary to support building decarbonization. So in the context of a broader social position, ASHRAE goes on to make these other statements: that the term decarbonization is being used to describe practices or policies that reduce greenhouse gas emissions, and that in the public interest, it is meant to address climate stability, public health, economic well-being, and the broader societal goal of sustainability. It also has a section that says in the position document, it's under the title of Society's Collective Best Interest. Under this paragraph, it goes on to say that addressing this issue is pivotal for current future generations, making it a collective responsibility to design in respect of. It goes on to say that embracing it is not just an industry priority, but a move in the best interest of the public at large. I think this is pretty impressive statements from ASHRAE. And then it goes on to say there's this urgency to this. It says that ASHRAE underscores the urgency, and that's a direct quote from this position document, ASHRAE underscores the urgency of decarbonizing buildings due to their contribution to global greenhouse gas emissions. And one of the reasons for the urgency is it's predicted that as of today, the global building stock will double by 2060. So that's a significant increase of actual buildings constructed here in the next, 35 years? So ASHRAE goes on to say, in order to address decarbonization, a holistic approach needs to be brought forward. ASHRAE commits to this approach by investing into research, analyzing what design strategies are conducive to decarbonization, provide technical guidance, help to support regulations at municipal and code levels, as well as be a resource for education. Well, it goes on to say that to support its sense of urgency, that the buildings we live and work in are responsible for roughly 40% of energy-related greenhouse gas emissions. And this is a considerable number, 40%. And when you take that into the context of the global building stock increasing or doubling by 2060, you can now see why ASHRAE uses the term urgency to help relieve the carbon burden the built environment is creating. Goes on to say that quantifying greenhouse gas contributions will be based on CO2 or CO2 equivalent values. Other greenhouse gases will be converted into the CO2 component to give it a CO2-EQ value. So there's a common value that is going to be referred to as global warming potential of these elements. You've probably heard of that for the engineers who are using refrigerants in your designs. You're probably asking yourself, what is the GWP or global warming potential of refrigerants? ASHRAE, it goes on to say that ASHRAE's membership has the expertise, mission, and vision to directly address decarbonization in existing and future buildings. So, looking at quantifying greenhouse gas contributions, building decarbonization encompasses a building's entire life cycle. And we're going to refer to this now because a number of times during this presentation, because decarbonization does not mean making operational efficiency greater in buildings. It expands far beyond that. It applies to building design, construction, operation, occupancy, and the end of life. The building life cycle assessment involves, and how to acquire that assessment involves, the consideration of operational and embodied emissions. So what are operational carbon dioxide emissions? It is the energy use of a building throughout its life. Operational emissions result in greenhouse gas emissions that are generated when a building is in operation to maintain thermal comfort and to provide a healthy environment. Then there's embodied carbons. There are embodied emissions, greenhouse gas emissions associated with building construction, such as extracting, manufacturing, transporting, installing building materials. Emissions generated from maintenance, repair, replacement, refurbishment, end-of-life activities, and embodied emissions that include refrigerant releases, refrigerant leaks, the loss of refrigerant during repair, and what those volumes are calculated to be at, how to address that. All of this is included in the embodied emissions calculation. So ASHRAE's commitment, what is ASHRAE's commitment to support their decarbonization agenda? Is to provide new technologies. ASHRAE is committed to continued efforts relating to the building decarbonization in the following areas: to provide more research and standards development, to provide design and equipment applications, to provide technical guidance and training, to provide regulatory guidelines and measures, provide educational resources and outreach to the community to support decarbonized designs. There's another section in the position document under positions and recommendations. And there's a subparagraph that states ASHRAE takes the positions that eliminating greenhouse gas emissions from the built environment is essential to address climate change. By 2023, the global built environment must halve its 2015 greenhouse gas emissions. All new buildings must be net zero greenhouse gas emissions in operation. Widespread energy efficiency retrofits of existing assets are well underway, and it goes on to say that embodied carbon by 2030 must be 40% of what it was in 2015. So the move of ASHRAE is to net zero carbon by 2050. By 2050, at the latest, it states, all new and existing assets must be net zero greenhouse gas emissions across the whole life cycle that I had brought forth earlier in this presentation, the whole life cycle of a building. Decarbonization benefits beyond reducing greenhouse gas emissions include reduced indoor and outdoor air pollution, energy savings, improved community health and well-being, and enhanced social responsibility, and even increased property valuation. So ASHRAE folds the social context into the realm of HVAC mechanical design. ASHRAE takes the position that operational energy-related greenhouse gas emissions can be reduced by implementing efficiency measures such as building electrification, improving operation and maintenance of buildings, the use of low GWP refrigerants and minimizing refrigerant volume used on projects, improving refrigerant management. So ASHRAE takes the position that renewable energy should be used wherever possible. Energy storage, as well as building grid integration and load shifting practices should be used to reduce the energy building that results in carbon generation. Building design and operation should be able to respond to real-time carbon signals of a grid that allows the shifting of load depending on areas within a neighborhood, within a block, or whatever, that need the energy at a given time where other buildings may not need that depending on time of day, building orientation with regard to the sun, etc., etc. ASHRAE takes the position that increasing stringency and enforcement of energy codes are critical for decarbonization. Goes on to say that whole building life cycle assessment, that it refers to with the acronym WBLCA, must be considered in the future of building codes. It goes on to state that building performance standards should be considered as a policy for existing building decarbonization. It takes the positions that decarbonization policies must consider and mitigate impacts on disadvantaged communities. Here we have the social element again. And it goes on to say building decarbonization strategies and policies must consider healthy, safe, comfortable environments, environmental and social impacts, sustainability, resilience, and economics. So its vision expands far beyond maintaining a thermostat at a set point within a building. ASHRAE then goes on to recommend that research standards and guideline developments should be practiced, promote research, develop programs that investigate and adopt building decarbonization strategies, promote research and development of heat pump technology. In fact, ASHRAE's Center of Excellence for Building Decarbonization has a 114-page document on how to design and lay out heat pump systems efficiently to reduce the amount of carbon generation in MEP systems. It goes on to say support the development, update, and adoption of relevant standards and guidelines that facilitate the whole life cycle reduction of GHG emissions. ASHRAE then goes on to recommend improved design and equipment applications, as well as workforce development. How do we support our service techs who are going to be encountering new HVAC designs when they're used to a thermostat and a package DX rooftop unit? So ASHRAE recognizes that need, and they're intending to address it. ASHRAE goes on to have commitment statements. It begins to expand on their commitments. ASHRAE is committed to develop and revise guidelines and standards to reduce building greenhouse gas emissions, to maintain and improving building indoor environmental quality, sustainability, and resiliency. It is committed to promoting whole building life cycle assessments and how to do that effectively to have accurate determining values, to collaborate with other organizations to help mutually support each other in decarbonization initiatives, to advance HVAC and R technologies and practices that minimize refrigerants impact, and to mobilize ASHRAE grassroots members around the world to encourage sound, balanced, and innovative carbon reduction strategies. And it goes on to say that is committed to take a leadership role in determining and harmonizing one set of aligned definitions and terminology for all building-related carbon terms. And that, I think, is powerful because if you read the standards or whatever, sometimes the actual terms used in various standards have different definitions. There's a lack of consistency. ASHRAE recognizes that, and they are moving in the direction to standardize terminology throughout their standards. So ASHRAE commits to the following: strengthen the decarbonization components of ASHRAE standards every 3 to 5 years, provide resources to support building performance standards, to develop and revise guidelines and standards to reduce building greenhouse gas emissions while maintaining and improving building indoor environmental quality, sustainability, and resilience. And I can assure you that there are ways, or there are system design concepts that will not only reduce the carbon burden of an HVAC system, it will improve the indoor air quality and consume less energy at the same time. So I could think of 3 right off the bat to do that, could easily take the place of packaged rooftops on the roof. Develop and revise guidelines and standards to reduce building greenhouse gas emissions while maintaining and improving building indoor environmental quality, sustainability, and resilience, and support beneficial electrification of heating through education, information dissemination, and focused training. And again, to reiterate, provide an educational platform to support our future service tech workforce in servicing these systems. The position document has an Appendix A. It is a consolidated review of all of the previous document. So I will do just a quick review of all of these items as I've spoken to a number of issues. It defines a building's entire life cycle as building design, construction, operation, occupancy, and end of life. It shows that building greenhouse gas emissions primary sources are construction, energy use, methane, refrigerant leakage. It expanded upon life cycle assessment and its importance for understanding not only operational CO2 emissions, but also embodied emissions. It goes on to be a state that it's a primary means for reducing greenhouse gas emissions by reducing building energy use through energy efficiency, reduce building embodied carbon, eliminate refrigerant releases, as spoken to earlier, energy efficient electrification, building designs to optimize grid flexibility and load shifting, provide on-site renewable energy, and to decarbonize the electrical grid. Appendix A also has a list of standards that address each and every one of these issues that are referenced here in this slide. Appendix A goes on to say that the United Nations Environmental Program has said that by 2030, the built environment should have its emissions compared to the 2015 standards. So ASHRAE has adopted the United Nations, the UNEP 2021 agenda, and it has also embraced the UN's 2050 net zero carbon whole life cycle objective and goal as part of its the ultimate outcome of the various standards that they've written. Appendix A also has a section on carbon reduction principles, another section on decarbonization strategies, and decarbonization challenges we just don't have time to go into today. So let's look at ASHRAE's Center of Excellence for Building Decarbonization. This is a site that is currently available on ASHRAE's website. Well, I find it rather interesting that on March 6, 2024, the Department of Energy issued the determination that ASHRAE Standard 90.1 2022 will be adopted as the energy performing benchmark for all future buildings. And municipalities, at least in the language, have 2 years to adopt that. The reason why the Department of Energy put forward that determination was that ASHRAE Standard 90.1 2022 adds 9.8% greater building energy efficiency than the previous 2019 standard. And let's give that some context. The 2019 standard added 4.7% greater efficiency to the 2016 standard. And that, from what I'm hearing from some engineers, that they're struggling to meet 90.1 2016 levels. So what this tells me is that with ASHRAE's stated commitment to decarbonization, its stated commitment for reducing carbon generations through HVAC systems will show that its building efficiency levels will continue to expand until it achieves its 2030 objective and ultimately its net zero carbon 2050 agenda. So ASHRAE on July 1st, 2024, published an article that celebrates the creation of their Center of Excellence for Building Decarbonization. The Center of Excellence took the place of the Task Force for Building Decarbonization. So you'll see that the Task Force for Building Decarbonization is gone away, and now ASHRAE will be referencing the Center of Excellence. The goal of the Center of Excellence is to strengthen ASHRAE's commitment to reducing greenhouse gas emissions. And it does this through various activities by strategizing on how best to do that through decarbonization efforts and to make goals clear and approachable. It is doing it through leadership and the writing of standards. It is doing it through collaboration for working directly with manufacturers, local authorities, engineers to demonstrate good practice for bringing about decarbonization policies, and public advocacy that educates why this has become a real need. The center goes on to say, join us to this journey to zero. And it expresses the pressing need, as did the position document, on why ASHRAE is adopting this aggressive program. Because again, it states on the center's website, worldwide building sector accounts for 40% of energy-related carbon emissions, and the global building stock is doubling by 2016. So consequently, buildings remain a key sector that today lacks sufficient climate change mitigation action. The center has a program expansion philosophy, and it recognizes that the scope of building-related policies, programs, and regulations need to expand to address greater energy efficiency, to provide beneficial electrification, and we're going to look at that more closely and what that means, demand flexibility, and we're going to look at what that means, and whole building life cycle greenhouse gas emission reductions. So let's look at the terms beneficial electrification. The center states that the beneficial electrification is the strategic use of high-efficiency, all-electric appliances and technologies to replace fossil fuel-based systems in buildings. Its purpose is to reduce greenhouse gas emissions, to improve indoor and outdoor air quality, increase energy efficiency, support grid decarbonization, and resiliency through smart integration. The term demand flexibility that the Center of Excellence advocates for is a building's ability to adjust its energy consumption patterns in response to external signals, such as electricity price changes, grid demand fluctuations, availability of renewable energies, utility incentives, and demand response programs. Now you can see perhaps why ASHRAE is addressing controls sequences of operations, sequences that will lend themselves to exploiting these objectives and put them into practice. Demand flexibility involves load shifting of energy, load shedding, load modulation, and energy storage integration. The program expansion goes on to adopt policies that concurrently will maintain comfortable buildings while being implemented, healthier buildings, safer buildings, buildings that have resiliency and can overcome perhaps a problem with the system and have the ability to respond to overcome perhaps a failed motor or a failed compressor or whatever, and to provide affordable building environments for occupants. The Center of Excellence has a header that has various links, and those links are Building Decarb 101, ASHRAE Decarb Technical Resources and Training Certification. We'll touch on what is in each of these here briefly. Under the Building Decarb 101 tab, you have comments that actually demonstrate ASHRAE's recognition of the significant source HVAC systems or the built environment have on greenhouse gas emissions. Building Decarbonization describes the methods that reduce human-made greenhouse gas emissions. It addresses whole life cycle costs within the 101 program, the primary means of reducing building greenhouse gas emissions, and new decarbonization policies are continuously developing. It also has a section under Building Decarb 101 of related outside sources. So if you wanted to pursue a certain topic more deeply, there is likely a resource available for you to do that. And it also has a frequently asked questions section. ASHRAE Decarb 101 also provides recommendations, commitments, and a view of the sessions relating to decarbonization, as well as awards, positions, recommendations, commitments, and it will more than be happy to have you volunteer to join ASHRAE's decarbonization platform and the Center of Excellence and its various initiatives. It also provides technical resources with upcoming guides, papers and proceedings, standards, position documents, technical resources, and all of these are downloadable on the Center of Excellence website. I thought one that was very important was the second from the left, the NREL document that addresses decarbonizing building thermal systems, a how-to guide for heat pump systems and beyond. Also, there's the GRIDA Interactive Buildings for Decarbonizations document that can be downloaded, as well as the decarbonization of hospital buildings. There's also a training and certification tab and a building decarbonization strategy game for you who want to immerse yourself into the initiative. So anyway, so what are ASHRAE's commitments to expanding upon standards to help support the design for decarbonized HVAC systems? Let's look at them. There's ASHRAE Standard 100, 2024, for energy and emissions building performance standard for existing buildings. There's ASHRAE Standard 90.1, many of you are already aware of, and its continual expansion. There's ASHRAE Standard 105, which is a standard methods of determining, expressing, and comparing building and the standard methods of determining, expressing, and comparing building energy performance and greenhouse gas emissions. There's proposed standard 228. Actually, it's no longer proposed. It is now a standard. 228 is a standard for evaluating zero net energy and zero net carbon building performance. Forthcoming are going to be standard 227, which is going to be on passive building design, an approach to HVAC design, I think, that offers an elegant solution for maximizing and optimizing energy efficiency and indoor air quality for buildings, as well as thermal comfort. And then ASHRAE has a proposed Standard 240, which is evaluating greenhouse gas and carbon emissions in building design, construction, and operation. So with that, we're going to conclude with a couple of comments. And here's where this is one of the reasons why I gave my disclaimer at the beginning of this session. We have to keep in mind that as ASHRAE moves forward with decarbonization, that ASHRAE does recognize the warming of planet Earth is occurring. It is measurable and it is validated. A major contributor to planet warming is due to human-generated greenhouse gas emissions that inhibit the level of energy irradiation back into space, tipping the energy level balance of our planet. Greenhouse gas contributions are measured in CO2 EQ values. So we have one metrics in order to assess how much greenhouse gas emission is actually being generated and ending up in our upper atmosphere. And they consist of the burning and combustion of fossil fuels, as well as the global built environment is responsible for 40% of greenhouse gas emission production or greenhouse gas production, and the HVAC system contributes to 40% of that 40%. So how HVAC systems are designed, operated, both in an operational sense as well as the carbon generations from in the manufacturing and construction process and life cycle of carbon generation is significant. To reduce greenhouse gas production within the built environment, ASHRAE has invested significantly to research standard and to research the issue of decarbonization further, to provide standards and to educate and provide guidance on how to reduce greenhouse gas emissions. ASHRAE's Center for Excellence on Building Decarbonization and other initiatives are industry resources to provide informed design practice to move the built environment toward net zero greenhouse gases for the built environment by 2030. Now is the time to join ASHRAE by applying their invested resources to reduce global greenhouse gas emissions. Questions?
There are not currently any questions in the chat. So if you do have questions, feel free to put them in there. There was one comment. Janice said the position statement on climate change is now in revision and should be out in a few months. She is on the revision committee.
Oh, very good. Is that Janice Means, Kelly?
Yep.
Our featured speaker in June. So Janice, thank you for joining us today.
Thank you, Dan, and you did an excellent job, as
Thank
always.
you. Thank you, Janice.
A lot of people wanting their PDH. Oh, here comes a question. Does ASHRAE provide future weather data for different regions based on the different RCPs for 2040, 50, and so on to base designs on?
ASHRAE does offer a document on climate. I have not studied it to speak or answer to that question. It's a good question, but I know that ASHRAE has a document on that, and maybe Janice has an answer to that because she's more deeply involved.
And she has her hand raised.
I wanted to address that. Thank you. I understand that when the handbook, the fundamentals handbook comes out, and it just went to press, I believe, a week ago Friday. So they're a little late on getting it out this year. But the chapter 14, which is on climate, will address this issue to some extent. But we still are relying a lot on our legacy 30-year values, but we're recommending in the climate change chapter. I'm also the chair of the climate change chapter for TC 2.5, which is climate change. And we're just recommending that everyone should look forward to what is anticipated to be happening, as well as looking at the 30-year that they always worked on. And again, chapter 14, which I have not seen a copy of yet, will address this to some extent.
And I know that in region 10 of ASHRAE, so Arizona, California, Hawaii, Nevada, we have been asking for an update on those 30-year data for a while because 109 for an ambient is a bit outdated. So I know that there has been a big push from our region. And I'm sure probably Region 9 as well, where some of you are from. So I'm hoping, Janice, that those changes are in that revision.
I will be addressing, I don't know. I haven't seen the actual copy, just in conversations with them. I think that there's some on there, but I will be addressing in my talk. It's not just only on climate change. I'm also looking at what is happening, what has happened, and what is expected to happen in the United States. And then I'm doing a special part on the Southwest United States, which is
Awesome.
heating up faster than the rest of the United States, especially, as I'm sure you're very aware,
Oh, joy.
Arizona is the hottest city. It's an increasing temperature much faster than any other city in the United States. Would you have it? If our memory serves, you think you had 107 days of over 100 degrees, and those were consecutive. Is that
Yep,
correct? Did I get
that
that
is
right?
correct. Yep. Unfortunately, that is correct.
Yeah, so I will be addressing that. Okay. I hope that's helpful.
Thank you.
Thank you, Janice.
All right. There are no more questions. If anybody does have any more questions, feel free to come off mute.
Kelly, I would like to close with this. A lot of engineers have not had the experience, nor have they've been challenged by building owners on exploring more efficient systems and how do you do that. Please know that we can support those initiatives on buildings moving forward. We'd be more than happy to have those discussions and evaluating buildings and solutions depending on the type of building, the size of the building, its mode of usage, etc. So there is a local resource available to help assess what type of design might be most effective in reducing greenhouse gas emissions in our geographical area.
Absolutely. Great point, Dan. All right. Well, I'm not seeing any more questions in the chat. So as always, if you do think of any questions after this, go ahead and email me, email Dan, email somebody at Varitec, and we will be happy to help you out. Oh, one question popped up.
Yes.
What about water or drought conditions and predictions for the future? Did you look at anything like that?
I can't speak to water. Maybe Janice has addressed that. I'm not aware of that being a part of ASHRAE's initiative.
It's not part of ASHRAE's initiative, but I will be touching on that again in my talk on June 18th.
Perfect.
It's not June 25th, it's
No,
June 18th.
it's June 18th, yeah.
Right.
The 25th, we're just coming back from the conference, so that's why we had to change the date.
That shameless plug is also here in Phoenix.
Yes.
Yes, as I mentioned in my disclaimer on that image, that some of the dates will change a week or two here and there. So, all right, great. We will see you there on June 18th. All right.
See you then, Janice. And thank you all for joining us today.
Yes, thank you so much.
Thank
We'll
you.
see you guys
Take
next
care.
time.
Bye-bye. Stay safe. Stay cool.
We'll try.
We'll try.